Today, as Jenna mentioned, we're going to talk about AI-driven test automation, evolution or revolution. And I hope that I can stir like your thinking about this topic into a pretty good way to position yourselves and your careers for the future that is ahead of us, right? So first, we're gonna just take a step back. I want you to think about how the world changes. You know, generally, we can trace the journey of advancements to early roots all the way to the bleeding edge. And by combining this historical perspective with the analysis of the current state of the art, it is my hope to reveal exactly what is changing, what is enduring, and actually what may be next on the horizon. So back in the early days, to very specific technological evolutions versus like revolutions, right? And I think for this, we can start way back in the early days of transportation. And you know, one of humanity's greatest engineering breakthroughs, guess what? Was the wheel in 3500 BC. And this is where mobility stopped being about human muscle and started being about mechanical leverage. It really was the foundation of transport technology. And that was typically thought of as like a foundational piece. And on top of that, we started with the domestication of horses. So horses added speed, strength, and range. And you know, as humans, this was our first step to outsourcing like mobility to another, you know, living creature, and that marked the birthplace of what we call horsepower. And it's still literally a term that we use today. And so while the wheel gave us motion, the horse gave us momentum. And so combining the wheel and the horse really produced a chariot, which was the first vehicle, true vehicle, I would say. Used in warfare, sports, and ceremony, it became a symbol of prestige. And as we move forward, our focus shifted from warfare to commerce and community. And wagons made it possible to transport people and goods over long distances. And this really was like a scaling moment, right? So the chariot served kings and the wagon served civilizations. And last but not least, we can think of the birth of public transport in thinking of stagecoaches or what are called horse buses. And the horse bus, which was first introduced in Paris, was the earliest form of organized transit. It showed that transportation had evolved from individual to more of a shared mobility. Passengers paid a fare, and that marked the start of what we call the transportation service economy. And, and you know, on top of all of this, it was really something that impacted our entire society. And so, if you think about this early stage and these micro evolutions across the board, like we had horses powering the economy. You know, they plowed fields, they hauled goods, they delivered mail. Armies ran on horses, commerce relied on them. And in short, if you removed horses, the economy basically stopped. And you know, on top of that, cities were built and designed around horses, right? So we had stables, we had blacksmiths, we had very wide streets to make room to accommodate horse-drawn carriages and wagons. The professions, labor, blacksmiths, you know, saddle makers, breeders, everything kind of surrounded, you know, this particular mode of transportation, this technological breakthrough. And, you know, owning a horse on top of that was a mark of wealth and freedom. And so the cultural identity actually and status was tied into this. So horse wasn't just technology, it was culture. And then came the automobile, right? So early cars actually were very clunky. They were expensive and very unreliable. Some of them are still unreliable today. And people mocked them as horseless carriages. And, you know, this is one of those things where under the hood, pun intended, since we're making jokes today, there was something radical and that was going to be very different about automobiles. You see, automobiles didn't just improve horses, they made the entire horse based system irrelevant because once automobiles arrived, you know, no longer did we need farriers. Instead, we had mechanics. There was new infrastructure. Roads were paved. gas stations, parking lots, traffic laws, all replaced stables and hitch posts. And there was also a cultural shift. There was no independence and personal mobility at scale. And so this is really the core of a technological revolution, is when a new system replaces not just a tool, but the world that was built around it. And let's zoom through some other examples, right? What better than to think of the world of computation and calculation? The abacus was humanity's first computing device, so to speak. Beads and rods guided the human hand. It required skill and it simply helped people to think faster. And over the centuries, we had these incremental evolutions. First, the mechanical calculator. This could perform basic addition and subtraction. It required you to do a manual crank and manual resets. But this was the first step towards automating arithmetic. And then came the adding machine, right? So we had a fully functional keyboard driven calculator. Each key represented a digit, and pressing keys directly added numbers mechanically. So here it was faster, it was more ergonomic, and it was a refinement of that mechanical computation, right? There was higher productivity and ease of use, but still it was purely mechanical energy and logic. And of course, we know that evolved into what we know today, our first electronic desktop calculator, which used vacuum tubes and cold cathodes. And now this truly was a bit of a revolution. You see, while each of these evolutions made arithmetic quicker, made arithmetic a little bit more portable, in general, though, the purpose, remained the same. It was an evolution of calculation and maybe a revolution in itself, but it was still powerful and very much human directed. And, as ironic as it is that we live in an age of computers, let's not forget that the first computer itself was really meant as just a giant calculator. Now it could compute things like artillery trajectories and so on and so forth, but it just really was a very fast calculator. And it wasn't until it was thought of that if you can actually reprogram it, then it could solve any problem. And that single idea, the programmable computer, is what changed everything in the world of computation. You see, the computer stopped being a tool for arithmetic and started to become a platform, even to today, of what we consider to be intelligence, right? From there came software, networks, automation, and even, yes, artificial intelligence, which is the focus of our topic today. You see, the computer wasn't just an evolution of the calculator, it was a true revolution. All right, and then just one more, just because I think it is also most relevant today. So in 1876, Alexander Graham Bell made the first telephone call from downtown Boston. And on this day in history, he exclaimed, "Mr. Watson, come here, I want to see you." And Bell wrote this account of his own words, transmitted via this new technology, and the world suddenly became a very small place. Right now, we had wired communication. Right, we had this, very old funnel-shaped mouthpiece that converted sound waves into electrical signals, and then a separate receiver. But it was truly revolutionary at that point because it made this whole idea of long distance voice communication actually possible. And then we went through a series of evolutions, right? We had the wall mounted telephone, then the candlestick, right, for its upright candlestick design and a separate earpiece. Again, ergonomics and maybe a little bit more stylish. And going all the way through to the rotary phone and then the push button phone till eventually even having a cordless home phone. Again, still wired technology, but now a bit more mobility due to the wireless, like local connection. And this was really a convenience upgrade at the end of the day within the same communication model. And of course, we know that today we're not really defined by wired communication only. We have truly wireless communication. And the thing here is that the mobile phone redefined not just communication, but work and lifestyle. And while we talked about the wired evolution, let's not forget that there has been a wireless evolution as well, where we started with a brick phone that had very limited battery life. But back in 1984 is when, communication truly became mobile for the first time. And then from there, we had the flip phone to what we see today as the modern smartphone. And, this whole idea of evolution and then revolution and this turning point for the phone really transformed it into, a digital hub for our modern lives. And now, we think of the fact that both the computer and software revolution, as well as the phone revolution, contributed to this software revolution. So we see that these revolutionary changes are also very cumulative in their nature. But of course, we can't have a talk about revolutions without talking about the Industrial Revolution, right? And in this case, there was a small number of innovations that were linked together. There were things like the textiles innovations, where we had mechanized cotton spinning. And around all of these micro innovations, you'll see that productivity was a core part of it, right? So, for example, mechanical cotton spinning increased the output per worker of the factory by around 500x. The power loom was 40x. We also had things like iron making and iron production. We substituted coke for charcoal that lowered fuel costs, and now we could produce iron, and we had larger blast furnace. We also had machine tools, right? The first machine tools were, these screw cutting lathes, right, and cylinder machines that just to us in these days would seem like archaic just because of how clunky and how big they were. But these were technological advancements that would become core. And one of the, I guess, central parts of it was all about steam power, right? Steam power was at the heart of the Industrial Revolution, and at the heart of the steam power that we had was indeed the steam engine. And so, thinking about transforming raw energy into mechanical work, this powered factories, trains, ships, mills, etc. But there's one more point that I want to bring up here, in that in some cases, sometimes these small evolutions um, that often, are these micro things turn into very large revolutionary pieces. And you see, steam, it was back then, the thing that powered the Industrial Revolution. But soon after that came the electric motor. And this started to quietly replace steam in the late 19th century. It had this, instant controllable power without boilers or smoke. And now we went into this decentralized power model. And the electric motor, similar to other revolutions, didn't just make steam better, it made steam obsolete, right? It replaced the entire system. And now I don't think we could think about our lives without thinking about electricity and how that really is energy that, is on demand and invisible and is a true technological upgrade. So why do I tell all these stories? Here we're here to talk about AI, but the food of thought here is what counts as a revolution. You see, a revolution requires scale of impact, right? It has to improve the outcomes within some existing system. It also positions the human role and relationship to technology. You see, in an evolution, the human remains in control of the process. However, in a revolution, the whole relationship shifts. You see, humans move from operators to orchestrators, and the focus is on goals and not mechanics. And also, there's a whole paradigm and mindset shift that happens with a revolution. You see, evolution builds on old logic, but revolution creates a new one. And last but not least, there's a key theme here. Of course, both in evolutions and revolutions, there are productivity gains, but evolutionary productivity is thinking about doing the same work faster. Revolutionary productivity redefines the work itself. And, evolution will give you speed, but revolution truly gives you scale and sometimes a whole new purpose. And one thing that I've highlighted here as well is that the final mark of revolution is that you can't really go back. Once the new model takes hold, that old way typically becomes obsolete and stops mattering. We won't go back to typewriters after computers. And I think in a similar way, there's some aspects of software testing that we won't go back to, which is the goal here in terms of our discussion. So just remember this: revolutions don't make things better, they make things different. And, one thing that I couldn't not put in here, since I'm an electric car enthusiast, is that this whole thing shows that there's multiple technological evolutions just coming together. This actually brings together almost everything we talked about, from transportation to computation to wireless communication, electric power, and of course, software, and now specifically artificial intelligence. And so AI, and I've spent a large part of my career focusing on artificial intelligence. And there's a couple ground rules that I want to make sure are very, very clear in terms of the foundational essence of this technology. You see, one of the key things here is that AI is guided by what is called the universal approximation theorem. And Ian Goodfellow mentioned that a simple feed-forward neural network, right? One of the most basic foundational forms of a very popular uh, ML approach is actually sufficient to approximate any continuous function. You see, this is why AI is so generally applicable across disciplines and industry domains. You see, when you think about it, we've applied AI to everything from identifying cats in a video to fraud detection and now to software engineering and testing. But really, the true progress wasn't because of this universal property. The true progress in AI has come from improvements in optimization and architectures that make AI very practical. And so we're living in the age of generative AI. And it couldn't be more true that, something really changed in 2022 when we had the release of ChatGPT. And it was not that generative AI in itself was not around. It had been around for a long time. But the transformer architecture did something to make these types of models very practical. And now we live in an age where everyone is hyper focused on leveraging this technology to become more productive. And it makes sense given everything that we said about revolutions, right? Productivity is normally something that is on the minds of folks. The question becomes, what type of productivity are we going to see? And will it be just evolutionary or will it be revolutionary? And the whole idea of the principle here, to bring it to Cypress.conf, is that this is acceleration through automation. And of course, software engineering is a hard problem. And so we're seeing this happen across the life cycle. And, it starts with identifying the key use cases. But of course, many of us have been focused on software testing. And can we truly automate software testing? You see, for a long time, we've actually settled for a very substandard definition of automation of software testing, where we still do a lot of things manually. But now we're sitting, and before we dive into talking about generative AI for automating software testing, understand that we're also still sitting even within a rapid evolution of generative AI technology. You see, in a short span, we've seen generative AI, in particular large language models, evolve from chats to co-pilots into almost a reinvention of what we call agentic AI. And you see, we started off because we would go to the LLM, right? We would go and ask Gemini a question, and we would go to that chat window and troubleshoot, maybe learn something new, but we could interact with AI. And then we saw this shift towards bringing AI to us. So we live in different tools and in different frameworks. And, we saw this co-pilot phase. which focuses on helping individuals in their role by bringing the AI capabilities to those tools. And now we're seeing more of an autonomous outreach where you want to have automated workflows across infrastructure and across teams. And this is where agentic AI comes into play. And so let's take a look at test automation. This is what we are here for. This is the stage that you've chosen to celebrate test automation this week. And when I think about this question, do we have a revolution or evolution? Again, I have to start by tracing this back to the early roots of this. And test automation has had its own evolutionary path. Of course, the whole idea was, could we make manual testing better? And we've gone through things like record and playback all the way to continuous integration. We've seen different tools from Selenium to Cypress. And so we're going to separate these things out into the different waves. But for sure, one of the biggest, type of evolutions that we saw was kind of going into, this scripted test automation era and thinking about scripts and then also thinking about frameworks that support them. And so that scripted test automation age, it was twofold. If you've been around long enough, you've used WinRunner and QTP. And I like to refer to this as that closed ecosystem where we had proprietary tools and vendor locked licenses. And of course, many of these things still exist. And we focused on functional UI automation, which was very brittle as well. And then we moved into more of an open source kind of code first perspective. And so we are writing this. And even I think within some of these things, you see that there's micro evolutions, right? Even if we think about the early days of Selenium, where you wrote code and it was pretty brittle. And then we start to move towards something like Cypress, which gives us a lot more baked in, a lot more of what we called the opinionated kind of batteries included type framework, where you worry about less and things become more stable. But beyond this, we're seeing the AI-driven test automation age. And, I was fortunate enough to be a big part of this early stages of this age. I've been looking at this topic now for a very long time. And, back in 2019, I published a book with O'Reilly on the topic because I had been working in this space as part of my journey with test.ai. And we looked at how we can automate using AI UI tests, right? Looking at single applications and mobile applications. We looked at how we can use that across application domains and test entire stores. We looked at very hard problems for testing things like video games and testing video quality. And so we saw that there is this evolution even of AI-driven test automation. It started pre those days looking at predictive analytics, right, for making software testing better and more efficient. We saw codeless and self-healing test automation, where we want scripts to be able to heal themselves. And this is something that was a byproduct of the fact that we had a lot of brittle scripts early on in the day. And then we saw, well, maybe there's a better way. There's computer vision based techniques, and maybe we can apply generative AI. Back then, before ChatGPT, there was still the idea of GPT and other models like recurrent neural networks and long short-term memory machines that could generate text. And there was people using that to generate unit tests and API level tests. And then thinking about non-functional testing. And of course, all that led up to generative AI becoming a big thing that made it a lot easier and, just a lot more ubiquitous for us to use. And then beyond that, now we're seeing this agentic world. So if I were to divide this space, I would take like, hey, if we look at this period here, this is the agentic test automation wave one, because AI agents are not new. However, once we got generative AI, which was a big step as well, we now had a new wave of agentic test automation. And it's important to position this very carefully for us because, we can learn a lot from these waves. You see, the first wave of agents, as I mentioned, um, comes with a grand vision, I think, where we saw testing can be better. We can do better than just writing scripts. We can generate things and we can apply testing at scale across all of the apps, not just testing one app. And to do that, we built agents that were built on computer vision technologies. Could we classify this image? And or could we actually detect certain elements within a particular image or objects in this case and do object detection? And then could we pull text from these images, right? So all this technology was continuing to grow in the world of AI, and applying it then to test automation meant things like detecting, what screen am I on, right? What are the elements? And using these techniques instead of using location strategies, pulling out textual information and then being able to leverage that to know what test inputs need to be applied, and then doing the same thing to identify failures and see when error messages occurred on the screen. And this was a pretty involved process. Like I had a team that was basically grabbing training data, samples of different UI screens or samples of different elements, and training classifiers. And it took a long time to train classifiers and test them, but it was possible. And then you could bring that together with the ability to navigate or explore an application using what is called reinforcement learning. So basically, having the machine try things and then maybe fail and then try again and improve, all using a reward system, right? So the machine would say like, "Hey, I want to navigate to the cards," and you give it a score, you give it a reward system. It tries to click something, it doesn't go the right place. So maybe you give it a negative reward. And then you continue in that manner where it finally gets to the goal and it gets the reward. And then your training session starts again. And then maybe it now hits, the right place and found a better path to it. And so this reinforcement learning by trial and error combined with computer vision was very powerful, but it required a lot of skill, a lot of expertise. And, it was just one of those things where, as you go through this, you realize how it was just not easy for anyone to pick up AI and build something with it. But we weren't the only ones, right? We had folks like the Diff Blue folks out in the UK doing generation of unit tests, using their own framework. And there was a lot of vendors that were at play, Applet Tools with their visual testing capabilities, and others just kind of popped up. And so all of this was wave one. And now we're living in a second wave. And as I mentioned before, it's important for us to understand the historical context of that first wave. You see, we had a lot of progress, but it was still very difficult to build. And actually, some of the things that we could do um, were very cool to watch, but we couldn't explain why it worked, and it was very cryptic at some cases. And people always wanted to see exactly what the AI was doing. And then comes along these generative technologies, right? So we specifically, when we talk about generative AI these days, most people are actually talking about large language models and our ability to, train a system to generate what is in essence the next word in a particular sequence, right? So a trained model can, generate coherent, hopefully, sentences, right? Or whatever would be the most probable thing to come next. And applying this technology to test automation meant now that natural language, right, as in say.prompt, becomes a core part of test automation. We don't need to be in the scripted era so much in terms of being hyper focused on technical scripts, but now natural language can become your means of communication to the machine, and you can write prompts and use them to execute tests and go across that stack. And in this case, being opinionated and being batteries included, you're not worrying about all of the different elements underneath the hood. It's something that could be very seamless to you as a test automation engineer or someone trying to build automation out. But if you want to peek underneath the hood, there's definitely a lot going on. You see, these aren't just models. Of course, there's a model at the foundation of it. But then on top of the model, there are tools, and the agents can interact with external data and services. And then on top of that, there's an orchestration layer. There's some reasoning going on. But if you start to think about us raising the level of abstraction, now you have these autonomous entities actually not just generating language and making decisions, but also taking action and orchestrating entire workflows. A part of this is a little scary, but there's sound technologies underneath there, right? There's reasoning approaches like reasoning and acting, where the agents think and act simultaneously. There's chain of thought, where you're asking the machine to think step by step. And if you need to evaluate different decisions, there's the tree of thought, which basically branches out into different paths. And so these are foundational things of this next generation of agents that we're seeing coming up. And some of that is done through making sure that we understand where this technology has limits. You see, when we think about large language models, these are pre-trained models. And so a user has to provide a context. You send context and you send a request, and you send that typically to a large language model that has been trained up to a particular point. And so that LLM has a cutoff date. And at the end of the day, there might be things that are outside of that knowledge that are external to what the LLM knows. And of course, if you provide context to the LLM and there's no external reference, the model can hallucinate. Of course, if you have a context and you have external references, but you don't have a generative system, you have a very rigid type of chatbot. These are like the first age chatbots that weren't very good at natural language processing. And of course, you can have that LLM and you can have the data, but you still need that user interaction. And it's at the center of this that we have what is called retrieval augmented generation, where these agents, given the requests, also can go out using their tools and external data and come back with a better result. And so we're seeing technological evolutions here, right? Improvements of this. And standardization starting to come, right? With MCP, the Model Context Protocol. So this is a nice uniform way to expose any data or APIs or pretty much anything that you want to your models. And this is exciting to understand what's happening here. At the end of the day, we need to be able to implement these agents. And there's frameworks that support that implementation. So agent development frameworks, things like LangChain, where you're now saying like, hey, this is how I can easily have a model be connected to tools and then spit out a result. Or if I want to have a multi-agent system, I now have things like LangGraph, where yes, there's a certain path that I might start down, but that might branch off and do more complex type of workflows. And it might also iterate and go backwards. And so this is impressive what we're seeing. These are definitely things that help us in building out quality engineering. And you can't forget that there's usually a human driver somewhere. So, for example, as a human, I could provide a behavioral specification that I want to have tested as part of a workflow. And it could pass that to an agent that reads that document. Maybe another agent compares it to some gold standard, right? That has maybe some examples of what good documents like these look like. And then the agent will try to evaluate it. And when it tries to evaluate it, it generates feedback. And that feedback is something that we might want to have another agent monitor and intercept so that a human could actually review it. And from there, maybe if the human says it's okay and updates it, then it can pass to another agentic workflow. So what we're seeing is that the future of test automation is relying on building these workflows. And at EPAM and Test.io, we've dived into building this sort of stuff ourselves. And you're starting to see these development environments where you can put conversations of participants, which are different agents as well as humans, collaborating to start, actually automating workflows, but still have the human in the loop. And with the human in the loop, it means that you're recognizing that these, generative models can indeed hallucinate. And once they hallucinate, they need to be kind of fact checked. And so I think we're going to start to see a lot more of this happening on a daily basis where humans and agents are actually collaborating. You're building these agentic pipelines. And then once the pipeline has, finished, you're reviewing the results of that. All right. So one thing that we can't forget that's part of this, second iteration of agents is the fact that in the test automation world, we love to focus on the UI still, right? And we've seen this kind of evolutionary step from leveraging just large language models to also having large vision models, right? So multimodal things where we can analyze images and go from there. But there's also large action models where we can look at sequences of actions that happen. And this is pretty impressive because now we have a second wave of agents, right? And this second wave of agents, this is testers.ai. So my buddy Jason Arbin is still at it, where you kind of have this multi-agent UI test automation, or you can do vibe testing, right? And you can really look at the capability as a step up from before. And it's not just functional testing, is all aspects of test automation at this UI level. And at EPAM and Test.io, we are also looking at this, but we don't build products per se, except for open source tools. We deal with services. So for us, it's all of the history that we just talked about, and how can we position this across the board to provide tools behind the scenes that allow us to give better outcome based and better services to our clients. Like, could we actually leverage this idea of agentic AI and generative models and the natural language processing to enable our own consultants and our own people to do better and faster testing? Like, is this the new way of doing testing and test automation? And so, I'll start to leave you with a couple of things here. You see, for end users, Gen AI made AI accessible, very usable and very visible, something that the people were asking for. But for us as engineers, as testers and developers, Gen AI is making AI infusible. It's becoming easier to integrate intelligence into applications, into models and infrastructure. You can now compose these types of intelligent systems from these modular building blocks and use MCP. For us as testers, it also opened up the black box a little bit, because now with models, you can ask it to explain its reasoning or justify its outcomes. And so testers can now probe and challenge and verify agentic behaviors. But more than anything else, it's making it indispensable. It's shifted from being a distant research concept, this whole AI, to now being a hands-on partner for coding and for testing and being used in our daily workflow. And so we can see like generative AI is helping us to automate testing and bring it to another level. And with that is also just quality engineering as a whole. You see, AI is accelerating the entire life cycle, including the development of what we call AI-infused applications. You see, there's a lot of dynamic behavior. There's adaptive AI systems which can adjust and learn at runtime. There's generative systems which create text and images and audio. And they're all very unpredictable, very non-deterministic, and very difficult to test. And there's a huge impact. Like, it can really damage us if AI doesn't align with our values. And this is something that we have to make sure that we're doing, is to make sure that AI is fair. And last but not least, like the systems that we build using AI components are very fragile or sensitive to data changes. You can change not only the output, but the complete infrastructure just with tweaking, the data. And so when we start thinking and talking about the future of test automation, um, I believe that the next shift is truly inward. You see, we've shifted left and we've shifted right, and we can't shift anymore, basically. And this is a topic that I actually studied a long time ago as part of my PhD dissertation. You see, back in 2006, there was a lot of big companies talking about building the future of software to be self-healing, self-configuring, self-protecting, and self-optimizing. And they were talking about using these autonomous managers, which were really just agents, to do that work. But what no one was talking about was the fact that we need to have self-testing as an implicit characteristic of these types of systems. And part of my dissertation was really just to focus on, could we introduce like a self-testing manager to actually test the other agents in the system? And so there's one more evolution that I want to talk about, or possible revolution. You see, about a month ago, I was at the Star West conference, and I saw Diony Santiago, who I've worked with both at Test.ai and back at Ultimate, present a keynote that was probably one of the best keynotes I've seen, called Agents All the Way Down. And in that talk, Diony actually talked about the fact that, this second wave of agents that are powered by generative AI need to do some testing on themselves, right? This is why he was talking about agents all the way down, because we needed to have these self-testing properties. And so I'm sitting there as he's referencing my dissertation, and then seeing what he's built, which is basically a very layered approach to thinking about first starting with static tests and then having self checks and then having tests being generated as part of this whole architecture and testing the oracles themselves and doing a lot of validation. And he did some live demos of agents, testing other agents and embedding that into the models, into Claude. And I sat there and I thought to myself, yes, this is where we need to go, because while we have humans in the loop and while humans need to test these systems, there's no way for us to keep up, and we have to turn the technology on itself. And so, evolution, revolution, I don't know. We've talked about so many examples of evolutions or revolutions within software testing and test automation. And you might be wondering, well, which is it and where do we go? And this is what I want to leave you with, right? You see, AI's role isn't about replacing you, right? A lot of people worry about that. Um, but what it is about, it's about evolution reaching the point of revolution. You see, in the game of chess, a pawn starts as a very simple, very constrained character, only able to move one step at a time typically. And this represents the early stages of automation for us. And every improvement, faster, better coordination, smarter positioning is evolutionary. But you see, when that pawn reaches the far end of the board, it is promoted. It is transformed into a queen, the most powerful piece in the game. And that transformation for us is not evolution. It's not just evolution, I should say. It is very much a revolution. And so, I think here we're seeing a simple fact is that we've evolved our tools step by step. And we've gone from manual testing to automated, from scripts to frameworks. But with AI, we've reached the other side of the board. And this moment is a promotion moment where that evolution culminates into a revolution. AI doesn't just move us faster, it actually moves us differently. It doesn't follow the old rules. It really rewrites our history and what we're going to be doing moving forward. So I encourage you. You see, one of the key things here is that as we go through all of this, and as we look at this evolution and these revolutions, we ourselves have to actually make some changes. We have to adapt and we also have to evolve. So I encourage all of you to embrace artificial intelligence, embrace what's happening around us. You see, why would you worry about your job or being replaced if you embrace this technology and you can leverage it to actually increase productivity? Then you become the orchestrator, you become more valuable. And you can also have an opportunity to become innovators, building the next generation of test automation tools and testing them so that we can actually get some gains that we've been waiting for a very, very long time. So again, I hope this has really opened your minds, and I thank you and very much open to questions.
Thank you so much, Tariq. That was an incredible way to kick things off for Cypress Conf. You've given us a lot to think about, where testing intelligence is heading, what it means for all of us in QA, and how do we balance that human insight and automation. I think we have a couple questions from the chat, so I'm going to go ahead and share one on the screen. So,
Sure.
with wave one and wave two already defined, and presumably more waves coming, how do we distinguish between multiple revolutions versus evolutionary waves within a single revolution?
Wow, that's a very good question and a very thought-provoking one. I think, going back to this is why I picked that example with the electric motor, because I think with the electric motor, it was one of those things where it was like, hey, we seem to have a problem here. Let's try to fix it in this way, and so on and so forth. And it was more of a gradual thing. And then you look back at it and you saw, boom, like this has changed everything. And I remember taking some leadership courses when I was a director. It's called Fierce Conversations. And one of the concepts in there was gradually and then suddenly. So what that really meant is that like these things kind of seem to be happening very slowly in our minds and bit by bit. And then when we hit one point, we look back and we see the dramatic change. Um, I don't think that you necessarily need to be able to distinguish these things to know exactly when what is happening. But what you should be conscious of is that a revolution happens in these two types of ways. Of course, when it happens instantly, it's very obvious. But just to know that it can happen gradually, just be on the lookout for what might be this gradual incremental thing and contribute to it if you can.
Awesome. We have another question from the audience. This one is from Brian. Do you think software development will move more towards TDD? AI doesn't seem the greatest at creating tests, but it's very good at turning tests into application code.
Yeah, so I mean, I don't know if we'll see like TDD being the mainstream way of doing this. And the only reason that I say this is that if there's something that you believe, right, like you're saying software development and code generation isn't necessarily like the greatest, like to generate tests. And it just seems like, hey, maybe these are superficial tests, but then you can take these tests and turn them into code. I think that with all of this technology, what usually happens is that AI isn't very good at first at doing anything. It requires input and usage, and for humans to really provide it with what that input is. So I would also expect that over time, AI should get better at creating tests and designing tests. Um, as long as we are feeding it and teaching it, and then someone is actually putting that into training data and training these models, or maybe specializing models for testing. TDD, though, is a great way to approach all of this at the end of the day, because tests are just, as you know, behavioral descriptions of how something should work. And I actually feel that maybe it won't be called TDD anymore. It'll just become the way to specify what AI should do. And so this is why I don't know if that will be coined, but maybe it'll happen anyway.